In this video, we'll look at making an exponential table and graph. We'll also calculate the domain and range, but I didn't put that in the title. So the equation is y equals 2 to the power of x, a very simple exponential function. I'm going to start with 0. That is 2 to the power of 0 in my table. Sub in 0 for x. What's anything to the power of 0? 1. So 2 to the power of 0 is 1. What's 2 to the power of 1? 2. What's 2 to the power of 2? 4. What's 2 to the power of 3? 8. See the pattern here? What's 2 to the power of 4? 16. So you don't need a calculator, but you could use one. What's 2 to the power of negative 1? Look at the pattern. 16, 8, 4, 2. Going backwards, what's this got to be? It's got to be 0.5. You can check it. What's 2 to the power of negative 1? It's 0.5, as expected. So feel free to use a calculator here or recognize the pattern. 2 to the power of negative 2, that's going to be 0.25. What's 2 to the power of negative 3? If you can't see the pattern or can't do that, a quarter split in half. What's half of 25? 12.5 or 0.125. Here, check it. What's 2 to the power of negative 3? 0.125. What's 2 to the power of negative 4? 0.0625. We got our table. That's it. All I did was sub in. But now I've got to make a graph of that. At negative 4, we're super close to the x-axis. Even at negative 3, this is 4. So we're basically right on the edge of that x-axis for a while. Here at negative 2, we're at a quarter. It's just going to come off a little bit visibly. And at negative 1, we're at 0.5, a little bit more. And then when we get to 0, we're at 1. Maybe a height here, but watch what happens. Classic exponential. Starts to shoot up. At 1, we're at 2. And at 2, we're at 4. Something in my throat. Keep going though, it's important. At 3, we're at 8. And look what happens with exponentials. They just rocket off. At 4, we're at 16. That's way up here. You can notice, whoa, my x-axis isn't labeled. Phew, there we go. You can notice that my scale is different too. That's okay. My x-axis goes up by 1 or down by 1. My y-axis by 4. But you still see this characteristic pattern. We got to connect the dots. Start really slow for exponential growth. But then rocket off. At a certain point, it just picks up and goes like that. And once you've got your graph, which you made from the table, the domain should be easy. Does it ever stop going left? No. Does it ever stop going right? No, it's going to get really steep, but it never stops going left or right. The domain is just the set of x is an element of R. The range is a little bit different. Notice that it can't go into the negative numbers. In fact, it's going to get close, very close, infinitely close to the x-axis, but never touch it. So what's the range? The range is the set of y is an element of real numbers with the limit such that y has to be greater than 0. I'll read that again. The range is the set of y is an element of all real numbers such that y must be greater than 0. Never equal to it, always greater than it. Can be anywhere up here. And we've done it. We've got a table, a graph, and the domain and range of an exponential.